Hashtag the solar system, a cosmic ocean of hidden worlds. There is a place so vast, so absurd, that even after centuries of looking up at the sky, we still know only a small part of it, the solar system. A cosmic ocean, where entire worlds orbit silently around a shared star, hiding extraordinary stories, frozen worlds, hidden oceans, gigantic storms, moons that might harbor life, dwarf planets lost in the darkness, and even regions so distant they seem to belong to another universe. For a long time we believed the solar system was simple, a few planets, a few moons, and nothing more. But the further we push into space, the more we realize we were wrong, because every new object we explore reveals something unexpected. Places where it rains methane, worlds hiding oceans beneath kilometers of ice, celestial bodies that preserve the remnants of planetary formation, and even possible giant planets wandering, invisible, at the edges of our own planetary system. Perhaps the most fascinating part of all this is realizing that each of these discoveries also tells a part of our own story. After all, the same elements scattered across these distant worlds also formed the Earth and formed us. In a way, exploring the solar system is like trying to understand where we came from and how far we can go. Our journey begins at the heart of the solar system. We'll dive into the interior of the Sun and discover that the light that lights up the Earth every morning began its journey thousands of years ago. We'll see how our star was born, how nuclear fusion works in its core, and why the Sun is one of the most violent and impressive machines in the universe. After that, we'll head to the Moon, a world that appears dead, but may hide billions of tons of frozen water beneath its surface. We'll follow the missions that completely transformed our view of Earth's natural satellite, and discover why finding that water could change humanity's future in space. Next, we'll travel to Titan, Saturn's largest moon and alien place that's frighteningly similar to Earth. There, entire rivers, lakes, and seas exist, not of water, but of liquid methane. We'll also see how the Cassini-Huygens mission revealed this world hidden beneath orange clouds, and why Titan is considered one of the most promising places in the search for life beyond Earth. Finally, we'll travel to the most distant and mysterious regions of the solar system. We'll explore the Kuiper Belt, look into the possible existence of an enigmatic planet, and understand why scientists believe a gigantic world might be hidden in the dark far reaches of our planetary system, well beyond Neptune's orbit. Buckle up. The journey through our planetary system begins now. Hashtag the Sun, birth of a star. Every time you look at the Sun, you're actually looking into the past. I know you're tired of hearing that the light we see actually left the Sun 8 minutes ago, because of the distance separating us, about 150 million kilometers. And in a sense that's not wrong, but the light warming your face every morning is actually much older. It began its journey thousands of years ago, before entire civilizations existed, before empires, before stories, even before the Great Pyramids were built. That's because before reaching the Sun's surface, it traveled an arduous path through our star's interior. And that raises an unsettling question: what's really happening inside the Sun while that light is still trying to escape? The Sun isn't just a fireball in the sky. It's an absurd, violent machine, almost impossible to comprehend, a place where matter stops behaving the way we know it, where particles collide with such force that they create pure energy, where reality itself is pushed to its limit. For a long time all of this was hidden. But now, thanks to space missions, we're beginning to see what's really there. And what's been discovered completely changes how we understand the Sun and even life on Earth itself. Before there was light, before there was heat, before the Sun itself existed, there was only darkness and a cloud, a giant, cold, silent cloud lost in space, so large it spanned unimaginable distances. But this cloud wasn't empty. It carried the remains of stars that died billions of years ago, fragments of ancient cosmic explosions, atoms that once were part of other suns, other worlds, other stories. Over millions of years, this cloud began to change. Slowly, almost imperceptibly, gravity started acting. Small, denser points appeared, pulling more and more matter toward them. The more they grew, the stronger they became, an invisible domino effect. Until, at some point, something happened, a nearby star died, and its explosion, a supernova, sent a shockwave through the cloud like a violent impact. It was the push that had been missing. From that point there was no turning back. Entire regions of the cloud began collapsing in on themselves, compressing, heating up, growing denser, until the matter stopped being just a cloud and began transforming into something new, something that didn't yet emit light, something dark, dense, silent, but already carrying within it the potential of an entire sun. This was the birth of the protostellar core. At first there was still no light. That dark core kept growing, pulling in more and more matter, compressing, getting smaller, denser, hotter, as if the universe itself were slowly squeezing a trigger, waiting for the right moment to fire. Then the temperature began rising rapidly, millions of degrees. The matter inside no longer behaved like anything we know. Particles collided non-stop, faster and faster, with more and more energy, until finally the threshold was reached, about 10 million degrees. At that instant, everything changed. Hydrogen atoms, the simplest element in the universe, began colliding with enough force to overcome their natural repulsion. When that happened, an absurd amount of energy was released. For the first time, the core ignited. That object, once just a dark mass, now began to glow. A star was born there, our sun. But while the star's heart was igniting, something equally important was happening around it. The huge gas clouds still surrounding it began to spin. That motion caused part of the matter to resist gravity. Instead of falling straight into the center, it spread out, flattened, forming a giant spinning disk around the young sun. And it's from that silent, chaotic disk that, over millions of years, planets, moons, comets, and eventually us would emerge. But all of this was only possible because of that one moment, the exact instant the universe stopped being just matter and began producing light. ## inside the sun's core. Igniting was just the beginning, because inside the sun there's a place that defies any attempt at understanding, an environment so extreme that the everyday laws we know simply stop making sense. At the sun's center lies the core, a region that occupies only a fraction of its size but concentrates almost all its energy. Inside, reality is brutal. The temperature exceeds 15 million degrees. The pressure is so absurd it reaches hundreds of billions of times anything we've ever experienced on Earth. There's no solid, no liquid, not even gas as we know it, there's something beyond. When you heat a solid, it becomes liquid. Keep heating it, and it becomes gas. But go further still, and the gas transforms, atoms start breaking apart, electrons are freed, and everything becomes a chaotic soup charged with energy. That's plasma, the fourth state of matter. And the sun is basically made of this, an incandescent ocean of charged particles moving non-stop, colliding, exchanging energy, generating gigantic electric currents. It's an environment so violent that atoms are constantly destroyed and recreated. Everything there is in motion, everything is unstable, and yet it's exactly this chaos that sustains everything that exists outside it, because it's within that turmoil that the sun finds the energy it needs to keep shining. So where does all that energy come from? What keeps this chaos active for billions of years without stopping? The answer lies in an incredibly powerful and energetic process, nuclear fusion. At the sun's center, hydrogen atoms are crushed together with such force that something seemingly impossible happens. They merge even while trying to repel each other, even while fighting to pull apart. The pressure is so extreme they're forced to stay together. And when that happens, they transform. Two hydrogen atoms combine to form helium. This process is known as the proton-proton chain, and it's responsible for practically all the energy the sun produces. But the most impressive part isn't the fusion itself, it's what happens to the matter in the process, because something disappears. When those atoms merge, the resulting product weighs slightly less than the original sum. A tiny bit of mass simply ceases to exist. But it doesn't vanish, it transforms. This is where one of physics' most powerful ideas comes in, described by Albert Einstein, the relationship between mass and energy, the famous E equals mc squared. This means that even a minuscule amount of mass can turn into a gigantic amount of energy. And the Sun does this constantly. Every second, it converts about 4.6 million tons of matter into pure energy, without stopping, without failing, without rest. There's an even more impressive detail: this whole system is perfectly balanced. While fusion pushes energy outward, gravity tries to pull everything inward, a cosmic tug-of-war. If fusion is too strong, the Sun expands. If gravity wins, it collapses. But for billions of years these two forces remain in near-perfect balance, a state known as hygrostatic equilibrium, a delicate stability that sustains light, heat, and life itself. But there's one last remarkable detail, because even after all this energy is created, it still has to escape. #the long journey of sunlight. After being created in that violent fusion process, the Sun's energy still has to do something nearly impossible: escape. But this doesn't happen quickly, in fact, it happens absurdly slowly. Inside the Sun, matter is so dense that light can't simply pass through. It gets trapped in a chaotic maze of particles. Every time a photon tries to move forward, it collides, gets absorbed, re-emitted, thrown in another direction again and again, like someone trying to walk out of a crowded mall with their eyes closed: no direction, no clear path, no easy way out. This process doesn't last seconds or minutes, it can last thousands of years. In some cases, more than 100,000 years just to get from the core to the surface. Only after that chaotic journey does the light finally break free, and only then does it cross space in a straight line, taking just 8 minutes to reach you. But by then it has already lived an entire history. During that journey, something even more incredible happens. At first, that invisible energy is carried in extreme forms, like X-rays, but as it moves through the Sun's interior it loses energy, slows down, and transforms until it becomes visible light, the same light that lights up our day, warms the planet, and feeds life, making everything possible. So next time you look at the sky, remember, what seems simple is actually the result of a process that took tens of thousands of years to happen, an invisible journey that began in the heart of a star and ended in your eyes. Because in the end, every ray of light that touches Earth is an ancient message from the Sun, and without it, none of this would exist. #the moon's hidden water. The moon has always just been there, silent, motionless, familiar. But what if I told you there's something hidden inside it that simply shouldn't exist? Water. Yes, water on the moon, a place with no atmosphere, exposed to the vacuum of space, with temperatures ranging from heat that could boil any liquid to cold more extreme than the coldest place on Earth. Logically, water shouldn't be there. It should have evaporated, disappeared, or simply never existed. But that's not what we found. Over the past decades, probes, impacts, and space missions began revealing signs of water in craters that never see sunlight, in microscopic particles scattered across the soil, and even in sunlit regions of the surface. But here's the problem: when we look directly, when we try to find that water, it's simply not there. It's as if the moon is hiding something, as if we keep seeing clues but never the full answer. That raises an unsettling question: where is the moon's water? Because finding the answer isn't just a scientific matter, it could completely change humanity's future in space. Lunar bases, fuel, exploration of the solar system, all of it depends on one thing that might be right in front of us, hidden under a layer of gray dust, waiting to be found. For a long time, the moon was considered a completely dead, dry, sterile world with no sign of water, and that made sense. With no atmosphere, no pressure, exposed directly to space, any water molecule would simply evaporate or be stripped away by the solar wind. Case closed. Until, in 1976, something unexpected happened. The Luna 24 mission landed on the lunar surface, drilled into the soil, and brought samples back to Earth. Inside those samples was water, a small amount, about 0.1%, but it was there. Stranger still, the deeper the material analyzed, the higher the concentration. That didn't make sense, but instead of triggering a revolution, the discovery was largely dismissed, since scientists reached a simpler, more comfortable conclusion: sample contamination. After all, earlier missions like Apollo had also detected trace amounts of water, and it always ended with the same explanation: error, impurity, human interference. So for decades the question went unanswered. The moon kept being seen as an absolute desert. In the years that followed, though, new missions began looking at the moon differently, not as a dead world, but as a puzzle, a place where something didn't add up. And the more we looked, the stranger it got. Even without knowing anything specific about lunar water, one thing was already clear: if water really existed on the moon, it couldn't be exposed, it couldn't be in plain sight. So the question shifted: where could it survive, in a place where nothing survives? The answer was in the extremes, the moon's poles. In 1994, the Clementine mission revealed something striking: there are craters at the lunar poles that have never received sunlight, never, in billions of years. That changes everything, because without light there's far less chance of heat, and without heat, water can survive. Inside those craters, temperatures plunge to around -173 degrees Celsius, with some studies suggesting they can reach -249 degrees Celsius, cold enough to preserve ice practically forever. These are without doubt some of the most dangerous places for lunar exploration. It was the perfect hiding spot, and that's where the hunt began. In 1998, NASA launched the Lunar Prospector mission, aiming to search for signs of water where no one had ever directly observed it. What they found was intriguing: large amounts of hydrogen concentrated at the poles. That could mean the presence of water, but it could also mean something else: hydroxyl, a similar but not identical molecule. It was a strong clue, but inconclusive. Then came a bold idea: if you can't see it directly, force the moon to reveal it. The Lunar Prospector itself was crashed into the moon's south pole. The idea was simple: the impact would kick up a cloud of material, sunlight would illuminate that dust, and telescopes on Earth could analyze what was there. It was the moment of truth. But when the dust rose, there was no clear sign of water. Nothing. The mystery continued. Years later, in 2007, Japan joined the search with the Selene mission: detailed mapping, high-resolution images, another attempt to find ice at the same locations. But again, the result was inconclusive. Even when the probe, like the earlier NASA mission, was deliberately crashed into the lunar surface, no direct evidence appeared. It was as if the water was there but always one step ahead, always out of reach, like a ghost hiding in the moon's absolute darkness. At that point, science wasn't trying to prove whether water existed anymore. The question had shifted: why was it so hard to find? After years of frustrated attempts, scientists decided to completely change their approach. If observing from afar wasn't working, maybe the answer was to get closer than ever before. In 2008, India launched the Chandrayaan-1 mission. This time there was something different. Instead of just observing the surface, they brought an impactor, a probe designed to dive straight into the moon, cross its thin atmosphere, and analyze everything during descent. It was risky, but fast and direct. For 25 minutes, that small probe fell toward the lunar south pole. And then, finally, the answer appeared: clear signs of water. Not assumptions, not indirect hints, water. For the first time after decades of doubt, science had real confirmation. A few months later, the Moon Mineralogy Mapper instrument, still aboard Chandrayaan-1, detected water again, this time directly from orbit. It was definitive: the moon wasn't dry. But NASA wanted more. So came one of the smartest missions ever conceived: LaCrosse. The idea was as simple as it was brilliant. First, a rocket stage would be launched into the moon's surface, hitting one of the dark craters at the lunar south pole. The impact would kick up a huge cloud of material, but this time they wouldn't rely on telescopes on Earth. The probe itself would fly through that cloud, analyzing everything from the inside, particle by particle, molecule by molecule. When the dust rose, it brought with it the answer humanity had waited decades for: water. But not only that, hydrogen, ammonia, methane, elements that could be turned into fuel and energy. At that moment the debate ended. The water was there, present, real. Today it's estimated there are about 600 billion kilograms of ice on the moon, an absurd number. But that only made things stranger, because if there's so much water on the moon, why can't we find it directly? At this point, since we already knew the water was there, the logic seems simple: go to the moon, look at those locations, and find ice. But that's not what happens. In fact, the more we look, the more confusing it gets, because the moon isn't like Earth. It's a place where water behaves completely differently from anything we know. During the lunar day, the surface can reach over 120 degrees Celsius, hot enough to evaporate any trace of water. But as we saw in the dark craters, the temperature can plunge to below -240 degrees Celsius, colder than Pluto. In other words, the moon is a world of extremes, and that's exactly what allows water to exist there, just not in the way we imagined. With the advance of the Lunar Reconnaissance Orbiter (LRO) mission, something unexpected was discovered. Small amounts of water are scattered across the entire lunar surface, not just at the poles, not just in dark craters, but across nearly the whole moon, in tiny, almost invisible quantities, trapped between grains of dust, the lunar regolith. But it gets stranger still. This water seems to move. During the lunar day it disappears. When the temperature drops, it returns, a cycle, in a world that shouldn't have water at all. That raises a new question: where does it come from? One possibility is micrometeorites, small fragments from space carrying traces of water that get deposited on the surface upon impact. Another hypothesis involves the sun itself. Solar wind, loaded with hydrogen, hits the lunar soil and reacts with oxygen present in minerals, forming hydroxyl, which can eventually turn into water. In other words, the moon might be creating water all the time. Over the years, several missions have managed to map more H2O on the moon. In 2020, NASA made a surprising discovery using SOFIA, an observatory unlike anything else, basically a telescope installed inside a modified Boeing 747, flying at over 12 kilometers altitude. It was there, observing the moon under infrared light, that more water turned up, but this time it was different, since it was discovered in a sunlit region inside the Clavius crater. That completely changed the picture, because until then it was believed water could only exist in extremely cold, shadowed regions. SOFIA showed that wasn't true. Even under direct sunlight, small amounts of water remain trapped within minerals or hidden between grains of lunar dust, an extremely small amount, much smaller than in deserts here on Earth, but enough to reinforce that lunar water isn't just hidden, it's spread out. In 2020, China's Chang'e 5 mission achieved the remarkable feat of bringing back lunar samples collected by its lander, about 1.7 kilograms. And guess what? More water. China repeated the feat with Chang'e 6 in 2024, this time from the far side of the moon. Another sample, more water detected. Yet even after these discoveries, when we try to physically find solid ice on the lunar surface, it simply doesn't show up. Recent missions like Chandrayaan-3 got closer than ever. They landed at the South Pole, analyzed the soil directly, measured its composition, explored the region, and still, no clear sign of frozen water. Nothing. This wasn't an isolated case either. South Korea's Danyuri probe, with its extremely sensitive camera capable of seeing inside completely dark craters, also failed to find what was expected. No large ice deposits, nothing visible, nothing obvious. This happens because H2O molecules are basically mixed into the lunar soil, making it impossible to visually distinguish what's water and what's regolith. However, a recent discovery may have changed everything. By measuring the temperature just below the lunar surface, scientists noticed something surprising. Within just a few centimeters of depth, the temperature drops drastically from extremely hot to negative in a matter of centimeters. That means one thing: lunar soil is a terrible heat conductor and an excellent thermal insulator. And that changes the game completely, because if heat doesn't penetrate, maybe the ice isn't just on the surface, maybe it's hidden just below it, out of our direct reach, out of our sight. And maybe it's not just chemically bound to the soil, but in its pure form, frozen water, like the kind we have here on Earth. If that's true, the question shifts once again. It's no longer where is the water, but how deep do we need to go to find it? The moon has always been there, seeming simple, silent, without secrets. But the more we look, the more we realize it was never just a dead rock in space. It holds something we've seen, measured, detected, but still haven't touched: water, hidden, fragmented, scattered, or buried, like an incomplete puzzle waiting to be assembled. And that changes everything, because this water isn't just a scientific discovery, it's a turning point. This water could become fuel, sustain life, allow bases to be built, and turn the moon into humanity's first real step toward the rest of the solar system. That's why today the moon is no longer just a destination, it has become a goal, a silent race. Missions are being planned, new technologies developed, and for the first time in decades, humans have returned to our satellite with the Artemis II mission. The next era of space exploration has already begun. But even with all this technology, all this ambition, one question remains unanswered. It's simple, yet powerful: where is the moon's water? And when we finally find that answer, it won't just be the moon that changes, it will be our place in the universe. And perhaps this journey is only just beginning. ## Titan, Saturn's alien twin of Earth. There is a world in the solar system where it rains fuel, a place where rivers flow not with water, but with liquid methane and ethane, where entire lakes and seas are made of something we put into car tanks here on Earth. And what's most striking, this world might be one of the places most similar to Earth in the entire solar system. For decades, no one knew what lay beneath. All we could see was a thick layer of orange clouds completely hiding the surface, a veil so dense it seemed placed there on purpose, as if that world were trying to hide something. Then NASA decided to look closer, and what they discovered was fascinating. Beneath those clouds is an active, dynamic, and incredibly familiar world, with weather, seasons, and rain. Yet, despite the similarities, on Titan the rules are different. The chemistry is different, the environment is extreme, and still everything seems to function as if nature had decided to recreate Earth in a completely alien way. And what NASA found there could change everything we know about life in the universe. Humanity's first close encounter with Titan came in 1979, when NASA sent a probe to explore Saturn for the first time, Pioneer 11. Among giant rings and distant moons, one target stood out more than all the others: Titan, an orange dot wrapped in dense haze, completely different from any other moon observed before. Scientists were eager, finally they would see what was there. But as the probe approached, nothing. No surface, no mountains, no detail, just a thick, impenetrable layer of clouds. It was like trying to observe an entire world through a curtain. But even without seeing the surface, Pioneer 11 achieved something crucial. It began analyzing that atmosphere, and what it found changed everything. Titan wasn't just another moon, it had a dense, nitrogen-rich atmosphere, very similar to Earth's. That alone was extremely rare. But it didn't stop there. Mixed in with that nitrogen was something even more intriguing: hydrocarbons, molecules made of carbon and hydrogen, the same elements that make up fuels and, more importantly, one of the fundamental building blocks of life on Earth. These structures are everywhere, in DNA, in proteins, at the base of nearly everything alive. And now they were floating in the atmosphere of a distant, cold, completely alien world. That was the moment everything changed, because suddenly Titan stopped being just another moon and became a possibility. But there was a problem: the most important part was still hidden. What existed beneath those clouds? Oceans, solid surfaces, or something entirely unexpected? Pioneer 11 had taken the first step, but it also made clear we were only beginning to understand that world, and if we wanted to know more, we'd have to go back. Even without being able to see the surface, the data sent back by Pioneer 11 was already enough to raise a question, something there didn't add up. Titan was enormous, actually bigger than the planet Mercury and much bigger than our own moon. But when scientists analyzed its gravity, something strange appeared: it was too weak for a body that size. That could only mean one thing: Titan wasn't made only of rock. In fact, it had to be composed of something much less dense: ice. And not just any ice, but ice so hard it behaves like rock. Suddenly the picture of that world began to change. It wasn't just a moon wrapped in clouds, it was a place with a completely different structure, almost a distorted version of Earth. A world where mountains could be made of ice, where the ground wasn't exactly solid like ours, and where physics seemed to work differently. Different, yes, but visually it might resemble our own Earth, at least a little. But even with all these clues, the truth remained hidden. All of this was based on calculations, indirect measurements, hypotheses. No one had seen this world directly, and what really existed down there remained a mystery. The more we learned about Titan, the more it stopped being just a distant object and became one of the most intriguing places in the entire solar system, a world that seemed familiar but at the same time defied everything we knew. And the only way to solve that mystery was to cross through those clouds. 25 years later, that's exactly what humanity decided to do. It took more than 2 decades of waiting for technology to finally advance enough to unravel this mystery. Then, in 2004, the Cassini mission arrived, one of the most ambitious ever sent into space, a joint project between NASA, ESA, and the Italian Space Agency. This time it was different. Cassini wasn't just going to observe, it was equipped to see the invisible, with radar instruments and infrared sensors capable of piercing through Titan's dense clouds. Finally, we would be able to see. When the first data started coming in, it was as if an entire world appeared out of nowhere. Beneath that thick veil of haze were real, complex, and incredibly familiar landscapes. There are rivers, valleys, plains, and something even more impressive, seas, not of water, but of liquid methane and ethane. On Titan there's a complete cycle, similar to Earth's water cycle, except instead of water evaporating and forming clouds, it's methane. It rises, condenses, and then falls as rain, yes, rain, on a world nearly 1.5 billion kilometers from the Sun. As for the average surface temperature, it's about -179 degrees Celsius, cold enough to turn water into rock, but curiously perfect for keeping methane liquid. It was like looking at a distorted version of Earth, where everything works, but under completely different rules. Cassini still had one more card to play, though. The probe hadn't crossed Titan's atmosphere itself, only measured it by radar. It would do that physically, through a small probe designed to do what no one had ever done before: descend through Titan's atmosphere. Its name was Huygens, a tribute to the man who discovered Titan in 1655. In January 2005, it began its descent, slowly suspended by parachute, crossing layer after layer of that thick orange sky. For the first time in history, we were about to see Titan's surface. As Huygens descended, images began to appear, first shadows, then outlines, then mountains, dark valleys cutting through the landscape, and something even more surprising: channels, entire networks of rivers etched into the terrain, as if liquid had flowed there for thousands of years. The probe was descending straight toward that region, and for a moment everything suggested it would land in a lake. But when it finally touched down, the truth was revealed: it wasn't a lake, it was a dry riverbed, a river that had once flowed there but was empty at that moment. Huygens hit the ground, bounced, slid a few centimeters, and stopped. And when its cameras began recording the surroundings, came the shock, because the most impressive part wasn't how alien that world looked, it was how familiar it was. Rounded stones scattered across the ground, as if shaped by flowing water, and terrain that resembled a riverbed here on Earth. But there was a detail: those stones weren't rocks, they were ice. Water ice, hard as granite. the mountains to ice. The ground, a strange mixture resembling damp sand made of organic compounds. And in the air, a constant, thick haze, almost alive. When Huygens pointed toward the sky, the sun appeared small and faint, just a tenth the size we see from Earth. And even though it was midday on Titan, the light resembled an eternal late afternoon, a twilight that never ends. At that moment, for the first time, humanity wasn't just imagining Titan, we were there. And what we found was an active, dynamic, and utterly unbelievable world. But even with all this, one mystery remained: where were the seas? Everything suggested they existed, but unfortunately Huygens had landed in the right place at the wrong time. The answer to the location of Titan's seas didn't come from a single image, it came over time, after years of observation. While the mission continued, the Cassini probe began analyzing Titan's regions in more detail, especially its polar regions. And that's where something finally appeared: reflections, bright spots on the surface, like giant mirrors reflecting sunlight. It didn't take long to realize that was liquid. Enormous lakes of methane. One of them was named Ontario Lacus, due to its resemblance to Lake Ontario here on Earth. But there was more. At Titan's North Pole, something even bigger was discovered: a true ocean. This is Kraken Mare, a colossal expanse of liquid methane covering hundreds of thousands of square kilometers, an alien sea that, incredibly, has tides influenced by Saturn's gravity. The ocean's level rises and falls, just as it does here on Earth. However, despite having tides, they're extremely weak, barely a few centimeters high. All of this makes these seas extremely calm, which defies what we would expect, because with a denser atmosphere and weaker gravity, the waves should be much bigger. But they're not, and we still don't know why. That makes clear Titan still holds secrets. But the surprises don't stop there, because this world is still alive, active, and dynamic. On Titan's surface there are volcanoes, but not volcanoes as we know them. No lava, no fire. Here, the volcanoes spew ice, a pasty mixture of water and ammonia that escapes from the moon's interior and spreads across the surface. These are cryovolcanoes, and they reveal something even deeper. Beneath that frozen crust there's heat, there's movement, and possibly an entire ocean of liquid water hidden and protected below the surface. And this is where everything changes, because there's hidden water, it's true, but it's there. And we also have abundant hydrocarbons. When these two elements meet, something remarkable happens: they form complex organic molecules, the building blocks of life. We're not talking about forests or animals, but perhaps something much simpler: possible primitive life forms that could exist in extreme environments like this one. So no, there's no evidence of life on Titan, but the conditions are there, and that means life may not be exclusive to Earth. If that's true, then Titan isn't just a distant moon, it's a natural laboratory, a cosmic experiment silently showing that the universe might be far more alive than we imagined. However, there's only one way to find out the truth: we need to go back, but this time not just to observe, but to explore. For decades, Titan was just a distant mystery, a silhouette hidden behind clouds, a world we knew existed, but never truly touched. Until now, because humanity is about to return. And this time it won't just be to observe, it'll be to actively, directly, and boldly explore. NASA is developing a mission unlike anything we've seen before. A machine that won't just land or drive on Titan, but fly over it. Its name is Dragonfly, a nuclear-powered drone designed to cross Titan's dense skies, hopping from one point to another, exploring completely different regions of the surface. It won't stay stuck in one place, it will travel, analyze the soil, collect samples, study the chemistry of that world in real time, and try to answer the question driving this entire journey: does life exist on Titan? Launch is planned for the coming years, with arrival around 2034. That may seem far off, but on the universe's timescale, it's practically now. And when that moment comes, for the first time in history, we'll have an active laboratory exploring a world that might represent a second version of Earth, not as it is today, but but as it might have once been, or as it might be in another corner of the cosmos. Because Titan shows us something powerful, life may not depend exactly on the conditions we know. It can arise in different ways, in extreme environments, following paths we don't yet understand. And if we find any trace of it, however small, that changes everything. It changes how we look at the universe, how we search for answers, and above all, how we understand our place in it. Because if there's even a small chance that something is alive beneath those orange clouds, then perhaps the entire universe is full of stories waiting to be discovered. And this might just be the first one. ## Planet 9, the hidden giant. For centuries, humanity looked up at the sky, believing we already knew our own cosmic backyard well. We learned the planets' names, calculated their orbits, sent probes to visit them, and even began dreaming of setting foot on some of them. At first glance, the solar system seems like a fairly organized place, 8 planets orbiting the Sun along well-defined paths, accompanied by moons, asteroids, and comets. But the truth is that when we look at the more distant regions of this system, we notice something curious: most of it is still practically unknown. Far beyond Neptune's orbit, where sunlight grows faint and the cold is absolute, there's a region so vast that even Earth's largest telescopes can barely see what's there. It's a territory of ice, darkness, and silence, a place where entire worlds could exist without ever having been seen. And it's exactly there that one of modern astronomy's greatest mysteries might be hiding. Scientists believe there may be a gigantic planet wandering at the edges of the solar system, a dark world made of rock and ice, possibly several times more massive than Earth. A planet so distant it would take up to 15,000 years to complete a single orbit around the Sun. It has never been photographed, never directly observed, and yet many astronomers are convinced it's out there. This hypothetical object became known as Planet 9. But that raises an intriguing question: how can we know something exists if we've never been able to see it? The answer lies in something nearly invisible, yet extremely powerful: gravity. In the universe, large objects rarely go unnoticed. Even when we can't see them directly, their presence can reveal itself through the way they influence everything around them. And curiously, this wouldn't be the first time a planet was discovered this way. To understand why so many scientists believe there's a hidden world at the edge of the solar system, we need to go back more than 2 centuries, to a discovery made by a man observing the sky with a homemade telescope, who stumbled onto something no one expected. On March 13, 1781, a musician and amateur astronomer named William Herschel was observing the sky with a telescope he had built himself in his backyard in England. That night's goal was simple: look for comets. Back then, astronomers spent hours scanning the sky in search of these icy visitors that occasionally crossed the solar system. It was during one of these routine observations that Herschel noticed something curious. Among the apparently fixed stars was a small point of light that seemed to move slowly. At first, he believed he had simply found another comet. But as the days passed and new measurements were made, it became clear that this wasn't a comet or an asteroid, it was something much bigger. Without realizing it, Herschel had discovered Uranus, the 7th planet of the solar system. It was the first time in modern history that a new planet had been identified. Curiously, Herschel wasn't the first person to see Uranus. The planet had already appeared on star charts decades earlier, but it was so faint and moved so slowly across the sky that everyone believed it was just an ordinary star. Only when someone observed its movement carefully enough was the true secret revealed. This discovery opened a new era in astronomy. For the first time, it became clear that the solar system could hide entire worlds that simply hadn't been noticed. But the most interesting part was still to come. As astronomers began studying Uranus's orbit more precisely, they started noticing something strange. The planet seemed to slightly speed up and slow down along its path, as if some invisible force were pulling on it. In space, objects don't change their motion without reason. When that happens, it usually means only one thing: another object's gravity is interfering. This phenomenon has a name in astronomy: gravitational perturbation. In other words, something invisible was influencing Uranus's orbit. The question scientists began asking was simple: what exactly was pulling on that planet? To answer that question, astronomers didn't immediately point telescopes at the sky. First, they did something even more powerful. They picked up paper and pencil and started doing math. Two astronomers decided to investigate this mystery using pure mathematical calculations, the Frenchman Urbain Le Verrier and the Briton John Couch-Adams. Working with the laws of gravity and orbital mechanics, they calculated where an unknown planet should be to cause exactly the observed behavior. In 1846, these predictions were sent to the German astronomer Johann Galle, who decided to point his telescope at the region the calculations indicated. Within hours, something extraordinary happened. There it was, Neptune, an entirely new planet. For the first time in history, a planet had been discovered through mathematics before it was ever seen. This changed forever how scientists would search for new worlds. And soon after that discovery, a new question emerged: if Neptune had been found that way, could there be another, even more distant planet? After Neptune's discovery, astronomers' confidence in mathematics grew enormously. After all, an entire planet had been found just by analyzing small gravitational perturbations. So naturally, scientists began looking for new irregularities in the planet's orbits, and it didn't take long for a new suspect to emerge. Some astronomers believed Neptune's orbit also showed small anomalies, a slight wobble that could indicate the presence of another, even more distant planet. The search for this unknown world then began. For decades, telescopes were pointed at the outermost regions of the solar system. Observatories began photographing large areas of the sky repeatedly, comparing images in search of any point of light moving slowly among the stars. That's how, in 1930, a young astronomer named Clyde Tombaugh finally found something. That small point of light received the name Pluto. For a moment, it seemed the mystery had been solved, the long-sought planet had been found. But there was a problem. As the years passed, more precise measurements began revealing that Pluto was much smaller than believed. In fact, it was too small to exert any significant influence on Neptune's orbit. To complicate things further, scientists realized that the supposed irregularity in Neptune's orbit didn't actually exist, it was just an error in old measurements. In other words, Pluto had been discovered, but it wasn't the planet scientists were looking for. Even so, this story revealed something important: if an object like Pluto remained unknown for so long, then perhaps the solar system still had many other worlds waiting to be found. And indeed, a few decades later, new discoveries would begin revealing that the region beyond Neptune is far more populated than anyone imagined. Over the past few decades, astronomers have begun exploring the regions beyond Neptune's orbit with much more attention. That's when a new part of the solar system began to reveal itself, a region known as the Kuiper Belt. There, an immense collection of icy worlds exists, fragments of rock and ice left over from the formation of the planets billions of years ago. Pluto itself is part of this region, but it's far from the only one. Today we know there could be thousands of Pluto-sized objects in that region, plus billions of smaller bodies scattered across the area. But as more of these objects were discovered, something curious began to appear. Some of them followed very strange orbits. Instead of being randomly distributed around the Sun, several of these bodies appeared clustered in the same direction, following long, tilted, very similar trajectories. It was as if some invisible force were organizing those orbits. In 2016, two Caltech astronomers, Konstantin Batygin and Mike Brown, the latter responsible for most of the Kuiper Belt discoveries, analyzed this behavior more closely, using computer simulations that reproduced the formation and evolution of the solar system. They tested different scenarios to explain those unusual orbits. When no additional planet was included in the simulation, the results didn't match what we see today. But when a new massive planet was added to the system, everything started making sense. The distant object's orbits aligned exactly as observed in reality. According to these models, this hidden planet should be 2 to 6 times more massive than Earth, orbiting the Sun on an extremely elongated path that could reach hundreds of times the distance between the Earth and the Sun. A single full orbit around our star could take up to 15,000 years. This hypothetical object became known as Planet 9. But there's one important detail: to this day, no one has ever seen this world. If Planet 9 really exists, it's probably wandering in one of the most remote regions of the solar system, so distant that sunlight reaches it only as a faint glow in the sky, a frozen, silent, dark world. Finding an object like that isn't simple at all. Even if it's several times more massive than Earth, it would be so far away it would reflect very little light. To most telescopes, it would be practically invisible, lost among billions of stars. It would be like trying to find a needle in a cosmic haystack. But that may be about to change. A short while ago, one of the most advanced telescopes ever built began operating, the Vera Rubin Observatory. Equipped with the largest digital camera ever installed on a telescope, it has an impressive ability to photograph the entire visible sky every few days. Over the next decade, this observatory will repeat that process thousands of times, creating something unprecedented in the history of astronomy, a giant time-lapse of the universe. Instead of manually searching for strange objects, scientists will simply be able to observe what changes between one image and the next. Anything that moves in the sky, comets, asteroids, interstellar objects, or even an unknown planet, will end up revealing its presence. If Planet 9 is really out there, hidden at the edges of the solar system, there's a good chance it will finally be found. But even if it doesn't exist, this search has already revealed something important. The solar system is much bigger, more complex, and more mysterious than we imagined. And perhaps right now, as you're watching this, an entire world is silently orbiting the Sun, waiting only for the moment humanity finally discovers it. #Dawn, a journey to Vesta and Ceres. In September 2007, a small spacecraft left Earth on a journey like no other. Its name was Dawn, and its destination, 2 ancient worlds drifting between Mars and Jupiter. Its mission was to visit Vesta and Ceres, the 2 largest bodies in the asteroid belt. The goal was to study these 2 worlds and uncover clues about the origins of the solar system. Vesta and Ceres are like cosmic fossils, time capsules holding clues about the formation of the planets, including our own. Visiting both would mean looking 4.5 billion years into the past, to a time when Earth was still just a sketch of a planet. For 11 years, this lone explorer crossed the darkness of space, sending back images and data that permanently changed our view of the solar system. But what exactly did Dawn find out there? What mysteries did it reveal about these forgotten worlds? After launching from Cape Canaveral in Florida, the Dawn probe began a slow spiral toward the outer solar system. It passed by Mars, using its gravity as a slingshot to gain speed, while the soft hum of its ion engines propelled it through the silence of space. It traveled 2.8 billion kilometers through the void, with no sound, and not enough heat to properly warm its solar panels. Then, in May 2011, a faint light appeared ahead. Vesta, its first image, captured from 1.2 million kilometers away, a small white dot floating amid an ocean of stars. In July of that year, Dawn entered orbit, becoming the first spacecraft in history to orbit an object in the asteroid belt. The images it sent back were striking: a mountainous world, sculpted by impacts and time, a survivor of an era of cosmic violence. The high-resolution photographs revealed Vesta's southern hemisphere for the first time: deep craters, huge scars, and grooves stretching across its equator. Each mark is a record of ancient collisions, some so intense they nearly tore the world apart. Each valley is between 15 and 22 kilometers wide and plunges several kilometers into the crust, reminders of the extreme battles from the early solar system. In the northern hemisphere lies one of the most iconic formations, a trio of overlapping craters nicknamed the Snowman, a curious, familiar shape in such a cold and desolate place. For about a year, Dawn orbited this battered protoplanet, mapping its surface and studying its composition. What it discovered completely changed what we believed about asteroids. Vesta wasn't just a rock, it was a world in formation, a planetary embryo that never finished the process. Beneath its crust lies an iron core, a rocky mantle, and a surface rich in minerals, the same layers that once shaped the Earth. Vesta, in fact, was one of the original building blocks of the puzzle that formed the planets. But that world wasn't the mission's only target, bigger plans awaited this incredible probe. After several orbits around Vesta and capturing spectacular images, it was time to leave. In September 2012, after a year of exploration, Dawn broke its orbit, turned its solar panels toward the Sun, fired its thrusters, and set off toward its next destination, the dwarf planet Ceres, a forgotten world between Mars and Jupiter. It took 2.5 years and another 4.9 billion kilometers of travel until, in March 2015, Dawn arrived at Ceres, making history again. It became the first spacecraft to orbit two different celestial bodies, and the first to visit a dwarf planet, months before New Horizons reached Pluto. From a distance of 13,500 kilometers, Dawn revealed a world never seen before, an icy sphere covered in craters, floating silently in the asteroid belt. Ceres is 946 kilometers in diameter, the largest object in that region. Its surface, though marked by craters, is surprisingly smooth, the result of a layer of ice that, over millions of years, softens and reshapes the terrain. But this isn't a dead world, it still changes and transforms, even if slowly. It was there that Dawn made one of its most mysterious discoveries. Inside a crater called a crater, the probe recorded bright spots that look like cosmic beacons lighting up the darkness. These areas are made of sodium carbonate salts, remnants of briny liquids that once rose from the subsurface and evaporated into space, clear evidence that Ceres once had geological activity. Soon after, another formation appeared in the probe's cameras, Ahana Mons, a lone mountain nearly 4 kilometers tall. But unlike mountains on Earth, it wasn't formed by fire, but by ice, specifically, by the eruption of a pasty mixture of salty water ice, mud, and other compounds. Data from Dawn suggested its formation is geologically recent, estimated at less than 100 million years old, and that this cryovolcano was spewing water until relatively recently, a frozen monument proving the dwarf planet's active past. Beneath its cracked crust, Dawn detected something even more extraordinary, signs of an underground salty layer, perhaps an ancient ocean that may have persisted until not long ago. Billions of years in the past, that ocean may have simmered with chemical energy, perhaps even warm enough to host the earliest precursors of life. It's fascinating to think that while Earth's oceans were still cooling, another hidden ocean between Mars and Jupiter may also have stood out beneath a crust of ice, before freezing forever. But Ceres's surprises weren't over. Among ancient craters and flat regions covered in fine dust, Dawn detected something that left scientists stunned: complex organic molecules, carbon-based compounds similar to those found in meteorites and, more importantly, in the fundamental building blocks of life itself. These materials were identified in an area near the Ernetet crater in the northern hemisphere. At first glance it was just another dark, unremarkable patch lost amid the dwarf planet's pale terrain. But under the probe's spectrometer, what seemed ordinary turned out to be extraordinary. These carbon and hydrogen-rich molecules weren't brought in from outside by some random impact. Everything indicates they formed on Ceres itself, the result of ancient chemical reactions fueled by internal heat and the presence of salty water beneath the surface. In other words, Ceres made its own ingredients for life. Just imagine a world so small and distant, yet with the same kind of chemistry that, here on Earth, ended up producing oceans, an atmosphere, and eventually beings like us. Combined with discoveries on moons like Enceladus, Titan, and Europa, this changes everything. It shows that the essential ingredients for life may not be rare at all, but part of the very fabric of the cosmos. And even if Ceres never harbored living organisms, it holds the chemical blueprint for how life can begin, a world that silently ran natural experiments for billions of years and is now handing us the results. However, as nothing lasts forever, after revealing many of the asteroid belt's secrets, the mission came to an end. In November 2018, after 11 years since launch and more than 6.9 billion kilometers traveled, Dawn went silent. Its fuel had run out, and NASA declared the mission over, but not its story. Today it still orbits Ceres, quietly circling the dwarf planet, and will continue to do so for at least another 50 years. Eventually, though, its orbit will decay, and the probe will slowly fall onto Ceres's surface, becoming forever part of it. As the probe continues its silent dance around Ceres, one thing is clear: this mission was more than simple space exploration. It was a journey through time. It showed us that even among the rubble of the solar system, lost in the asteroid belt, there are ancient stories waiting to be told, stories of worlds that almost became planets, of oceans that once shimmered beneath the ice, of mountains that once spewed water instead of fire. #conclusion, a universe still full of mysteries. Looking back at the primordial solar system and glimpsing the birth of planets like our own, it's impossible not to wonder how many other forgotten worlds are still waiting out there for us. How many secrets still lie hidden in the darkness between the stars? We can only wait for probes and telescopes, ever more advanced, to gradually reveal the mysteries of the cosmos to us. In the end, perhaps the greatest discovery isn't about planets, moons, or stars. Perhaps it's about ourselves. Because the more we explore the solar system, the more we realize it's far stranger, more complex, and more alive than we imagined, a place where oceans might exist hidden beneath kilometers of ice, where seas of methane reflect the light of a distant sun, where entire worlds remain invisible in the darkness, waiting to be found. For a long time, humans believed Earth was the center of everything. Then we discovered we were just another planet orbiting an ordinary star. And now we're beginning to realize something even more astonishing: perhaps the universe is full of places capable of holding the ingredients for life, just as happened here. That thought is almost frightening, because every probe sent into space, every telescope pointed at the sky, every new discovery seems to open even more questions. What exists beneath the frozen surfaces of these moons? How many unknown worlds still silently orbit the sun, and how far will humanity manage to go in the coming centuries? Maybe one day cities will be built on the moon. Maybe submarines will dive into Titan's seas. Maybe probes will cross the hidden oceans of frozen worlds. And who knows, maybe right now, at the dark edges of the solar system, there's a gigantic planet we don't even know exists yet. But regardless of the answers, one thing is already clear: the solar system isn't just the place where we live. It's a gigantic cosmic machine, full of mysteries, stories, and extraordinary worlds waiting to be explored. And perhaps the most incredible part of all this is realizing that this journey is only just beginning. Thank you.